Okay, I'm going to get going. So, okay, there we go. Got the thumbs up. All right, welcome to BSUG, everyone. We have a special guest today. You are all probably familiar with Jake. Jake's back today. He's going to be talking about his experience integrating performance and simulation at a design firm, and he calls it trials and tribulations, so that should be interesting. Jake has his master's degree in architecture from the University of Idaho. His professional background has included research, sustainability consulting, education, and architecture. He worked in London for ARUP in their Foresight Innovation and Incubation Group for about a year, I believe, and then came back and worked here at the University of Idaho Integrated Design Lab for 4 years, where he did simulation, energy efficiency research, teaching, and did all kinds of analysis for us. Did a wonderful job. We do miss him. He was then recruited to Eskew+Dumez+Ripple, where he is tasked with enabling evidence-based design simulation and analysis to their firm there. And he works with design teams to explore the link between aesthetics and performance through simulation and a scientific approach to sustainability. So we're excited to hear from him today. And here's Jake.
Great. Thanks, Katie. That was good on sound. Very nostalgic to hear that intro for BSUG program that I helped run and took over from AIA for a while. So it's great to be back in Idaho. It's great to be talking to this particular crowd today. I'm so thankful for all of the information that I learned from the lab about sustainability, simulation, and performance, and to be able to take that out to the professional world and come back and kind of share some of those lessons here today. It was a fantastic time to reflect on that as I was making this presentation. So I'm really, really happy to be here. And so I always kind of start off my presentations in New Orleans with this photo, kind of showing where I've come and where I'm at currently. And just appreciation for the beauty of the natural world is something that I'm really excited and thankful to have in both places. Very different, right, in terms of the climate and the overall scenery, but that appreciation is still there, and it forms a lot of my ethos around sustainability. So that's been fantastic. So presentation title. At the core of this presentation is really this question, right? How do we integrate sustainability into practice? And it's something that I've been concerned with ever since leaving academia in the research and consulting world and going to Eskew+Dumez+Ripple, which is a design firm that's kind of operating regionally and also nationally in the U.S. And so to unpack this statement, because I think it's really important to break some of these words down from a rhetoric standpoint, is, it was in the intro, right? What do we mean by sustainability? And from the lab's point of view, which has kind of reflected my view of it, is about performance-based design, right? So it's how do we inform design decisions through data, through evidence-based design, and start to kind of inform design decisions by looking at things like energy, daylight, performance, and simulation. So it's really taking this rational and quantifiable approach to sustainability. Integrate is a really important word as well, and this is kind of the bulk of this particular presentation, but really tried to frame everything as actionable exercises that you can take back to your firms and start to implement them, right? These are actual things that we can put a tag on and understand them and understand how they might actually get integrated into a design process. Because I think at our core, a lot of us want to do more sustainable work. We want to integrate this into our design processes, but unless we really know how to do that, it becomes this black hole that's hard to touch and bring into a project when you're staring down 5 other different deadlines and working 50-hour weeks. So I think it's really important to really frame it as actionable. And then practice too. So how do we move beyond just having an impact on a couple of projects and really affect our entire portfolio, right? How do we enact the change at the scale that needs to happen to truly make a difference? And this goes beyond just working for clients that are championing sustainability and trying to elevate all the projects across their entire portfolio, even the ones that don't necessarily have design goals. So that's going to really be an important part of the presentation as well. So where I come, also here's another way to view it. This is the entire watershed of the U.S. Just love the graphic in general. So I worked in the lab for about 4 to 5 years before moving to Eskew+Dumez+Ripple 2 Junes ago is how I frame it now. So about 1.25 years is what I'll be talking about, all the stuff I've done in that particular time. A little background on Eskew+Dumez+Ripple. We're a firm of about 50 people. We focus primarily, Charlie, within the region post-Katrina, kind of focusing our efforts on rebuilding community, and have kind of worked to kind of move beyond the regional scale recently. And in 2014, we were honored with the 2014 Architecture Firm Award by the AIA. This was before I got to the firm, so I can't take any credit, but I think it speaks to the level of design excellence that the firm tries to achieve across their body of work. But the main reason why I went down there was that the firm, one of the core values is sustainability, right? So we have a sustainability action plan. We're signatories to the AIA 2030 commitments. We're doing benchmarking on projects, or they were, doing benchmarking on projects. But then also we teach at local universities and are dedicated to research, instrumenting buildings from a research standpoint. All those things create a fantastic environment to come in and try to do this type of design. So one of the questions is, who is this presentation for? This is our firm, so we're right at about 50. So I would say, it's most applicable towards medium-sized firms that are Revit shops, essentially, because we have converted completely and only use Revit primarily for our projects. And I think it's still applicable if you're a smaller or larger firm, and if you don't use Revit, I think there are some universal concepts that you'll be able to glean from the presentation. But really who this presentation is for are the firms that want to do more sustainable work, but don't quite know how to get there, right? So my hope is to provide some roadmaps and some actionable items for us to take back. But since all my experience comes from working for this particular firm, this is the kind of typology that we're looking at. So the presentation is organized as a series of questions. We're going to talk about structure, we'll ask some questions about tools and actions, and primarily for this group, I really wanted to focus on the bottom two so we can get some insight into workflow on how we're using different simulation tools to do this type of analysis for some of the projects that we've been working on as an architecture firm. So the first question is, how should you structure your design teams? And this is going to be different for every team, but there are kind of two main typologies that we run into. This is a snapshot of our firm. We have 2 partners. We have 6 principals. It's kind of changed a little bit since I made this diagram, but the principals have a horizontal crossover role. We have a series of design teams that have project associates / managers, and a series of design staff that can be project architects, junior staff, the whole spread. And then there's me down here, right? And Z is our director of building performance and sustainability. So in this case, you've got kind of top-level support. We've got one dedicated position to sustainability, and then we would form some type of group that we would handle projects and get projects from the other design teams, do analysis, give them back, and go deep on these particular projects. So this is the typical model, and it's great because it allows you the kind of depth and freedom to kind of really do some hardcore analysis, but you kind of don't have as broad of an impact as what we were looking for at the firm. So the other alternative model, and this is what we're piloting, is this sustainability champion / enabler model, where we still have the top-level support at the director level. There's still me down here, but now we've actually identified one person in each design team to be our sustainability champions, that where we meet every 2 weeks, and I teach them how to do simulation skills, right? I teach them analytical processes. We bring up their fundamentals. We kind of get them trained up to essentially be what we've done here at the lab, right? To have the technical expertise to do some of these calculations to help inform that performance-based. And so this has been working out well. There's some trials and tribulations, going back to the title. So there's a couple of failed assumptions that would make this model even stronger. So I'd like to talk about these because I think they're really important into kind of how we're starting to move forward into this kind of second year of my tenure at EDR. So, one failed assumption was that train them and they will simulate. That's all they need. So everything, it's just like a floodgate, right? As soon as we train these folks up into being able to run, energy simulation and daylight modeling, that the project managers would just ask for it and we'd all be simulating everything, would be great. This was a failed assumption because it's much more complicated than that I learned moving into it. And a lot of it is just also wrapped up into this idea that junior staff will advocate for sustainability. The learning curve for learning some of these tools, as we know, is pretty tough, and even if you're able to get proficient at actually creating the data, it's a whole nother level to be able to interpret that data into good design, right? So you've got to be able to run the tools consistently, QA, QC, and then also be able to intelligently talk about them in a design critique when you've got your design director there to be able to affect that change. And that's just a lot to do for the kind of junior staff that we had recruited as sustainability champions. So there are kind of different backgrounds, different levels of passion, reasons why they're interested. Some volunteered, some were volunteered, but they're all kind of at that junior level. So really looking back on this, we really needed to target some of the design staff, right? Some of the project architects that are interested in sustainability, because they're the ones where this kind of feedback loop and having those design skills will make the most difference. So for instance, if we go back to that centralized model, someone gives us a task, do some simulations. It might take me 4 to 8 hours, right, to get it, run the analysis, package the results, give it back to them. And in 4 to 8 hours, that design could have completely changed, right? It's happened so quickly, and design is so idiosyncratic by the groups to really distribute it and have those key individuals, I think, would be the strongest form of this particular type of model. So we've kind of retooled a little bit in trying to adjust this moving forward, kind of based upon this quote that my director sent me recently, which is, if you want to build a ship, don't drum up people to collect wood. Don't assign them tasks and work. I'm great at doing that, though, by the way. But rather teach them to long the endless immensity of the sea, right? So it's really about the passion of wanting to do this. The only way when you're working, long hours and you're, got 5 deadlines to deal with, that you're going to incorporate some of this, because at its nature, it's disruptive, right? It's going to be disruptive until people completely change the way that they set up the beginnings of projects to kind of accept this type of analysis. So that's something that's, got to be really cognizant of moving forward. And it also makes this question equally as critical as the kind of infrastructure question, which is, how do you cultivate a culture of sustainability? I would say about half of the firm is into sustainability and really believes in it. Half of us are lead APs. We go out, we try to get lead work. We do that documentation. But at the same time, half of us aren't. So there's this kind of culture shift that needs to happen to where those project associates will start to ask for these types of analyses from their junior staff, from the sustainability champions. So, I could give an entire lecture on the myriad of things that we're doing to promote this culture. But the most appropriate one for the talk today is benchmarking, right? And this is really critical in terms of, you can't manage what you don't measure. There's a lot of things that I think we should be tracking about our designs as architects, not just researchers from when I was at the lab. And really it's about accountability as well. We want to be able to have this up on the wall so we can have informed discussions about how are we doing as a firm, how are we doing as individuals, and how are we going to do in the future. So in terms of what should we track, deceptively simple, surprisingly complicated, right? So these 3 things, if we can track these on every project at the firm, a job will be done, right? If we can do that. So, number 1 is we always want to know what the benchmark of our project is, and what's the energy goal. So, we have CVEX, we have these national databases, we have Target Finder from Portfolio Manager, we have local data to where we can start to understand what are we comparing our buildings to, right? We did a lot of that here at the lab. Number 2 is what is the predicted EUI? So this comes from the energy model from the mechanical engineer or early conceptual modeling from the architects. And if you're signed on to the AIA 2030 commitment, you're required to report this every year anyway. But really, it's one number, but it would be nice to know during the different phases of the projects. You can kind of adjust and understand your trajectory, and that makes it a little bit more difficult to get that number as well. And then number 3, well, energy use intensity. So really about going back, understanding how is the building actually performing, because that's where the rubber meets the road when it comes to carbon or when it comes to really affecting the built environment. It doesn't matter how well you design the building if you don't have the occupant engagement and the systems in place to make sure the operators can actually handle that level of design. And what's interesting is if you're interested in design awards, like our firm is, this is required in submissions now. And this number is going to be required for future submissions. So that's one thing that the AIA is doing to kind of drive this type of work. It's going to just be the natural evolution of what we're trying to track in terms of our projects. So some of the structure that I've helped set up at EDR is to kind of capture and document this information is we set up a series of online SharePoint forms using InfoPath. SharePoint form is a love-hate relationship with it in general. But this allows the sustainability champions to kind of fill out these forms per project phase for each one of the projects in their design team. So they're able to include, distributions of data from CBEX. They're able to kind of put in the various other types of benchmarks. There are areas for looking at project goals in terms of energy, daylight, water, and this is supposed to kind of document those design goals. Then also, this plugs into a database on SharePoint to where we can pull everything for our reporting for AI 2030, Architect 50 magazine, all of those things, right? So we have an online form that kind of tracks these different benchmarks that we use as a database, and also we use as a pinup artifact, right? So this is actually supposed to be a portrait, and this prints out to an 11 by 17 that we can pin up next to design reviews. So it's essentially that scorecard, right? That kind of shows us, you know, what are our benchmarks, what are our design goals, and are we meeting them? So my ultimate hope is that, you know, there's a design review up, this is off to the side, the project manager can come up and say, oh, well, looks like our EUI is 49, looks like our target's 32, let's work on that. Looks like we have not run a daylight simulation for this yet, so let's go ahead and make sure we staff appropriately. And then also looks like our stormwater site calculation is yet to be done. And then, of course, these numbers are the kind of targets for each one of those. And so as this progresses down the design process, you know, we have that record of how it evolves with it. So I think it's important for this to be kind of visual as well, to kind of bring up that culture, have people ask for it, and understand what it is. The logical conclusion of benchmarking is to do these sustainability reports that some of the larger firms are doing in general, and it represents kind of the highest evolution of where benchmarking can go. And so I just want to briefly mention this is RTKL's sustainability report. I think they're probably doing some of the best work in the industry on benchmarking, and I just wanted to flag it here so you guys can go check it out down the road. You know, they publish one every year. It's graphically beautiful. They're reporting everything from, you know, revenue from green building projects to they're reporting scatter plots of, you know, cost per square foot versus energy savings. I mean, they're really highly evolved when it comes to what metrics they're looking at to help market this design and help them get projects down the road. So that's one great use for benchmarking. But okay, so that's kind of the culture and some of the structure that's set up. I think it's really important to talk about because you can't just have the simulation capability in-house, right? It takes more than that. It takes more than that passion. A whole host of infrastructure and pieces need to be put in place to really set up an environment where this can be at its most effective and efficient. So, you know, that's why I spent so much time on that first part. But what I really want to talk about for this crowd is tools and applications. So first off, you know, what design and simulation tools are appropriate for architects specifically? This was something that I was concerned about when I was at the lab, and now that I'm in the profession, I've got a new perspective, and it's been an interesting road. But the maturity of the BIM integrated simulation tools really makes this possible for there to be in-house simulation capabilities for architects. And that's kind of two different workflows. So the one that we use at the office is all the kind of Revit building performance analysis suite of tools that they've been developing. So there's Revit architecture, which is kind of all consuming now. There's Revit MEP, which is part of Revit architecture. So if you've got that, you have access to some of the MEP analysis. It's really complementary to the other energy analysis tools in that it does scheduling really well, plugs into the building information model. It does loads modeling on a space-by-space basis, and I've got an example of that. Then Green Building Studio was kind of the first iteration. This is the kind of cloud program that runs the energy simulation, sends it to DOE 2.2, brings it back in. You can do like more advanced analysis on the web. But kind of two new tools that have made this workflow, I think, even better is Projectslon, which is a visualization tool. So you can actually do custom visualizations, which was greatly needed. And also it's given us some parametric capability. And I've got an example of how we use that in the office as well. And then last but not least, there's the lighting analysis extension for Revit. We call it LAR. And this is the single point in time analysis plugin for Revit to where you can run lead calculations directly within the Revit environments. You can do illuminance renderings for kind of a qualitative perspectival look at your design. It also does lead reporting just straight out, so it makes that process much easier to do. So, but it's still single point in time, and it's still being developed. But we've been using it pretty successfully on projects, and you'll see how moving down the road. The other workflow that's a really contender is the Sapphira workflow. I didn't include it here because I could talk for days on the differences. But the structure is similar. There's a Revit component, there's an online component, and there's a mechanical component. And if anyone is curious about that, we can talk more after the presentation. So to talk a little bit about how we use Revit MEP in this architecture firm is, first step is that we actually have spaces. And for whatever reason, there's a schism between architects use rooms and engineers use spaces, right? They do different things for the two different disciplines. But now that they're all in one package, it's fairly accessible to do both in one project, and it offers some opportunities. There's automatic space placement now, which makes it a lot easier. And there's also add-ins that you can download, space naming utility, to kind of associate them with a room name. So it's really easy to set up a space model from an architectural room model. So then the second step is, you select it just like a room. In the properties dialog box, you have access to all of your energy modeling inputs, both at the building level, at that individual space level, so there's a hierarchy. You also can put in internal loads, people, all those things are accessible directly, in that space-based properties object. And then step 3, there's a higher level up, so space level and then building level, and it's really like 5 different inputs to actually get a model going and running that's good enough for architectural analysis, right? If we're looking at kind of building form, envelope, rotation, and stuff like that. So this is a fairly simple workflow to get to be able to report heating and cooling load calculations. So we've developed some schedules that we're starting to implement in some of our templates and projects to where, we can report the name, here's the space type, you can see if it's inheriting the space type from the building, or if you're putting in something at this level, you can sit down with the architect and kind of go through these, make sure they're appropriate. This is also reporting the outputs in terms of the cooling and heating loads, and also you can start to look at some of the other model inputs. So this is a fantastic QA/QC and reporting tool that all plugs into the Revit kind of functionality with schedules. It's been a nice transition going from Microsoft Excel to Revit schedules. It's been nice. And then once you actually have them reported in the schedule, you can place them in room tags and do visualizations of your plan similar to this. So this is one that we've developed to look at calculated cooling load, the colors representing increasing levels of the cooling load as a BTU per hour per square foot. And this number can be really important. It drives system type, right? So if you're doing, radiant systems or chilled beams, you have to be below a certain threshold so you can get a visualization of what tool or what spaces to kind of look at and understand. And it's also a proxy for comfort and energy, right? So to get to this level, it's fairly automated at this point, and it's a great visualization. The space load report also gives you the breakdown of those loads in their overall modeling report. So we can see for this cafe, it's like 49 BTUs per square foot, which is pretty hot. And it gives you a breakdown of where that's actually coming from. So we can see that 52% of that load is from the people assumptions because it's a cafe, high use, high density. But the walls and windows account for about 32%. So what is this material? What's that glazing strategy? Is there room for manipulation? This type of feedback starts to help inform those types of decisions. All right, so that was some examples of how we have used Revit to kind of leverage some of the energy modeling tools. Now let's talk about some actual exercises and case studies that can be applied to early design. And then we'll talk about late design and post-design as we progress. Big table, I'll break it down though. So energy programming. This is something that we talked a lot about at the lab, and I was really excited to be able to take it to EDR because I think it's something that is absolutely critical for a variety of different reasons. At its kind of most basic, you're looking at space info. It's just like regular programming. You're looking at adjacencies. You're looking at design criteria, per space, correlated on the plan with colors. But you're also adding performance criteria. So the idea is when you're looking at temperature ranges, natural ventilation potential, in this case it's all lighting criteria, this is a restaurant that we're working on, that you'll be able to understand relationships by having that information in front of you. So it's really important from a design standpoint. It's also really important from how we interact with our consultants, right? So we created this table that we put in our project definition document that we will then solicit a electrical narrative, design narrative from our consultants. About 50-50 though, we get this table from our consultants, and then we can have an informed design about, what is the horizontal illuminance level for a dining room table? What is the contrast ratios that we want to achieve in terms of a romantic design intent, right, for the dining room? All those things, we can start to have that information, and this can be a document that we refer to throughout the entire project. So we're going to kind of follow that through briefly. So This all comes from the IES&A Illumination Engineering Handbook, the giant tome. I know there's one in the office. We have one at EDR. But it's really just recommendations. So they say 3-foot candles at a dining room table, 3-to-1 ratio. So it's 3 to 9 is what they consider is appropriate for dining. Well, we did some lighting audits of some other restaurants as a way to kind of embody this knowledge, right? What does 1-foot candle look like at a dining room table? What is the contrast ratio of this environment, and do we think it's good, right? Because we really need to experience what these numbers mean as a way to really start to understand what should their criteria be. So in this case, it's all at about 1-foot candles. So if they did want to go with a low contrast environment, the recommendations would be to be 3-foot candles kind of everywhere, or go to the 3-9 or 1-3 to understand how those ratios translate to design. But this is something that we can do on a lot of our projects, and I would encourage you to do it for projects that you've worked on or projects that you think are good and bad examples. It really just takes doing the most basic HDR photography to get a better kind of visualization. Then we have illuminance meters that we go out and we just tag different areas and throw them on a plan, right? Very informative, very easy to do. Then at the lab can load those tools out. You can even go one step further and do kind of luminance analysis with a luminance gun, which would be great if we had access to that in Louisiana. But they're like $6,000 to buy one, and there's no lab to rent one from. So this is something I think that we can all do moving forward. And the last piece of this, this actually starts to move down in terms of more detailed analysis. In Revit, it's becoming really easy to do electric lighting simulation, right? As architects, we're placing lighting fixtures because we want to control the way they look. It's just one additional step to add the IES photometric file to those families to get an accurate distribution of light in the space. And using some of the simulation tools, you're able to report it like this, and then compare this and what this data is telling us to what our design intent was from our energy programming exercises. So, is this beam spread appropriate in terms of hitting that table? What is this ratio, and is that appropriate for our lobby or entry space? What's going on in the kitchen? Are those levels appropriate for food prep? This is that loop of evidence-based design that I think is really apparent when we're looking at electric lighting in simulation in this particular example. And then you can also do the perspectival false colors. It's only luminance, not luminance, unfortunately. But this can be an interesting design tool as well. This is that same project. We had located some can lights above the stairwell to actually bring light all the way down and kind of draw you up through the entry sequence. And doing these scientifically accurate simulations with the photometric files, we found that we're not getting that effect. So we're able to adjust appropriately. So that was kind of a very clear use of the simulations of design intent, quantifiable and qualifiable visualizations to understand how we're doing in terms of design. So that's kind of energy programming carried through. One other really easy thing to do is advanced precedent research. So I imagine all of us include precedents in their early conceptual design reports, whether it's pre-design, conceptual design, project definition is what we call them. We all generally include precedent images. One thing that I've been encouraging our managers and sustainability champions to do is to actually list, and this is straight out of one of our reports, so it's a little small, but the actual EUI of those precedent images. So we can start to be more informed about, okay, well, how is that building actually performing? How does that compare to our listed goals according to the 2030 challenge, right? So this is for multifamily. 50 EUI is the national benchmark. That's the #1 of the benchmarking trifectorate. We have our goal, and we know it's 70% savings over the national average. And these are all projects from the COAT Top 10 winners, so they list their energy use. And so, they're at 44, 27, 31, 80. And how does that relate to our goals? It's just trying to inform the conversation a little bit more. So you can find energy use for buildings in a variety of different places. COAT Top 10 website's one, High Performance Buildings magazine, all their case studies have energy data. And I think the High Performance Buildings database also shows energy data. So I think that would be one thing that would be useful when we're starting to talk about energy use and simulation. So the next thing is matrix design. So this is early design, let's say schematic design, and I love this photo. Can't believe I was able to find Keanu Reeves with a matrix of Keanu Reeves behind him into infinity in the matrix. But it's really important because I have a hard time justifying early conceptual design on a variety of different projects, right? I've been trying to implement it a lot at the firm, And it's really hard to find like a good slam dunk because, for instance, if you're just kind of doing a typical building and you're looking at 20% versus 40% window to wire ratio, you don't need a simulation to tell you, how that's going to look, right? Or how percent daylit it is. And you might not even care when you're just doing initial form development. So, fundamentals and rules of thumb can go a long way for a lot of different types of projects. It takes a very specific type to really warrant early conceptual modeling. One of those formats is when you're doing iterative analyses, when you have very different iterations for a project early on, and you're actually looking at very different forms. So for instance, this is a multifamily project that we're working on, luxury condos in New Orleans, and essentially we're looking at 3 different schemes in terms of, I think there's 300 units each. They're all roughly the same square footage, and they're kind of loaded differently because they're responding to access to natural ventilation, which is pivotal in our climate, solar control, and also solar access, right? So each one of these are dealing with those in different ways, then also different ideas about the design of the site. So, if you're looking at 20 to 40% window to wall area ratio on this, it'd be fairly easy to understand intuitively where it's going to go. But if we're trying to compare all 3 of these, I think that's a great use for simulation moving forward. So directly within Revit, we kind of isolated a section of each one. We ran daylight simulations to get percent daylit, essentially using the LEED criteria. We're also able through Green Building Studio and Projectslon to get energy and use breakdowns for each one of those projects. And then we also just took a percent distance from the envelope or from the perimeter to determine percent naturally ventilatable is the term that we were using. Of course, keeping an eye on wind direction to make sure that we can channel breezes through dock troughs and stuff like that. So the way that we report it in our for the client is through something like this, right? We create a matrix to where we understand what are the important performance criteria that we want to be tracking, and then we can compare them across the different options. So we can see that energy performance, despite them being very different formally, is not super sensitive in this case. But daylight performance there's a 30% spread, right? So this gives us a good way to start to evaluate these different design decisions. And I think this is only really one half, right? This is just looking at performance. The opposite end of the spectrum is, some of you might recognize this. This is the IRIC building on Moscow's campus, designed by NBBJ, and they sent us this matrix at the end of their schematic design phase. And I was like, this is great. This is a matrix design. They've determined what are their kind of critical aesthetic criteria. They have a sustainability section. They have this kind of 1 out of 4 scale. And then, they used it to help evaluate, what design they were going to do. But the sustainability is really, how well does it respond to energy? Is it climatically responsive? There's no quantification of that. And with these tools, we can do this large-scale energy modeling to where we should have like an EUI value, percent daylit, as part of this, so we can look at, once again, both aesthetics and performance. So I think if we were able to combine this with this, we would have a fantastic matrix that we can use to help rationally evaluate design decisions. So actually, moving on to this one. So this is still early design. And another kind of good application of early conceptual modeling is really to determine what are the design constraints, right? This is something that we can do before we even have a good idea of what the overall building form and even program is going to be. So for instance, one of the project managers came to our group and said, I've got a multifamily project coming down the pipe. It's going to be a series of apartments for St. Bernard Parish. And essentially, it's in New Orleans. The site's off-axis, so it's pointed towards southwest, much like our grid in Boise. Challenging orientation. And they were really wanting to know what's the impact of orientation and building form on this project, because we know, just from fundamentals, that a bar is going to be the most appropriate in terms of, running east-west, solar control, but an L shape would fit the site better. It would solve some of the programmatic and site constraints a little bit better as well. So what's the penalty from that perspective? So I'm like, great, we'll use the Revit early tools. We'll design a simulation study to start to answer this type of question. So here it is in Revit. There's the kind of suite of energy analysis tools. If you've set up the spaces, these are already there. There's a variety of different granularity that you can get into. This is pretty coarse, but it's totally fine for this level of analysis. You can see it's doing some auto zoning. You know, you still put in the 5 inputs to make sure it's multifamily and giving it the schedule and the right site. But you're able to get a lot of information with a relatively few amount of inputs. So we run this simulation, and their standard report looks sort of like this, right? And so this is directly within the Revit environment. You get a little bit of information about EUI. You get some loads breakdowns, you know, across the year. But this information isn't that accessible. Like, we don't have overall energy and use breakdowns. I can't like click on any of this and understand, you know, what percent is from solar load. This is pretty granular in general. So we didn't use this tool a lot because it was so simplified. But now with the kind of advent of Projectslon, and now that we can have this custom visualization capability, we're actually able to use those tools and get them a lot farther down the road. They're much more useful now. So essentially with Projectslon, you create each one of these kind of reporting widgets, and you can, you know, vary the type of reporting, pie chart versus bar chart. You can look at things, you know, total energy and use breakdowns, and for a variety of different metrics. So it's very flexible, and you can pump them into dashboards, into the Revit families. So these run every time you run that simulation. So it's automated at that point once this gets set up by someone in that kind of sustainability infrastructure. You can see that they're also interactive to some extent. You can hover over, you can get the actual values, you can turn these on and off. I mean, it's a very fantastic, flexible tool. So Salon was usually just for visualization. Now they've created something called run sets, which actually changes the game, I think, once again, and allows us to leverage the Revit modeling tools. The run sets are essentially their ability to do parametric simulations. So you can use the run sets to package measures. You can use them to turn the building in a packaged way so it runs every time. And they're very flexible as well. And this is for Revit and their tools, because Green Building Studio kind of does this in the background already. So if you remember that Revit slide, there's Revit MEP, there's Green Building Studio, there's Projectslon, and there's the light analysis for Revit. This is the Green Building Studio. And you can see that it runs like hundreds of simulations in the background that you can access through their online interface. But this is really inaccessible, right? I mean, this takes like 5 minutes to pop up. You know, you can report each one out, but they've kind of combined things in unintuitive ways, and you can't really understand what's been simulated. So I think Projectslon was a way to say, okay, well, instead of doing this brute force method, let's give people the ability to design their own parametric simulations. So this is what that starts to look like. This is the online interface. You kind of set up one of these run sets. Here's all the different parameters that you can affect. It's fairly simplified. This will get, I think, more in depth, but you can do everything from HVAC to constructions by facade, infiltration, light and power density. All of this is accessible to you. So you create the name. We added a rotation parameter because we're looking at orientation. We also want to look at window specifications between 2 different types. This is the rotation parameter, and then this is the glass that's applied on every orientation for that particular run. So we did one, changing it 30 degrees at a time, set this up. 0.25 is the code maximum SHGC in Louisiana on zone 2. So I mean, I knew that this was going to lessen the sensitivity on orientation, so I wanted to be able to communicate that. So we did one at 0.25 and we did one at 0.7. So yeah, so we've got name, orientation, and glass specifications. We make the run sets, we add them to widgets, we add them to the dashboard, and then it runs automatically anytime we hit that run simulation button in the Revit environment. So this is an example of the output of those 2 widgets that we did, right? So this is the orientation plus window at 0.7 SHGC, and this is 0.25 SHGC. You're still a little bit limited in some of the metrics you can do. So the run sets come out as US dollars per square foot per year. Of course, you can modify the utility rates, at a different inputs. Here's all of our different runs that we set up. You can see that it rank orders them, so it's not turning it, but it's actually reshuffling them. And then this is the overall proxy for energy use according to US dollars per square foot per year. So this tells us a lot of information just having these 2 things run, right? So the difference between these worst case scenarios is 15%. Between the 2 cases. Best case scenarios, it's 3%, right? And that's just because the nature of orientation will make it less sensitive to some of the solar gains and losses that are being experienced. So I mean, I think that at its base level can be interesting. Also watch out for the axes are cut off as well. Can't control that in the widgets yet. But what we mainly wanted to understand is, for those conditions, what's the sensitivity according to orientation? So if we look at our code window, it's 2.5% difference. And that's just because the glass is so high performance, it really lessens orientation overall. But if we looked at an existing condition, or maybe something that was in a different climate zone, where the SHUC is 0.6 as the max, 0.4 in some cases, then we actually get a much larger difference. So this starts to talk about how orientation is not necessarily a driving factor in this particular case for that project. So, this can go in the project definition report. It's helped illuminate one of the design constraints, and it's an infrastructure that we've set up, and now we can run this for any project that we want. So it really starts back to the question, what are some of the other factors that might affect that sensitivity? What if we add external shading? What if it wasn't multifamily and it had daylight harvesting? Then that would definitely affect it. What if we had all of our glazing on the southern facade and no glazing on the other facades? All those would be really easy to change in the Revit model and then rerun using those widgets. So we were starting to use run sets and Projectslon more and more to help leverage that. So we made some for the Advanced Energy Design Guides. So we start to understand baseline in the Advanced Energy Design Guide potential for any project that we run, and it happens all behind the scenes. So that's one good way that you can, once again, leverage the Revit infrastructure and use it for early design. So let's talk a little bit about some late design projects, because I think these tools are applicable across a variety of scales and timelines. So this is a small project for Tulane. It's the Tulane River and Coastal Center. And we came in very late in the project. I think this is right after I got there. This is the first project that I worked on. And we wanted to make sure we were achieving the LEED credit and providing good space for the inhabitants. So we came in and we looked at the window design. And in the end, we went from a 69% daylit building to 79%. Very late in the game, 90% CDs. It wasn't too late to make those changes. And of course, this crossed the threshold into allowing us to report the credit. So what this process looks like is, this is what comes out of the Revit lighting analysis for Revit tool. This is a training space, offices, lab buildings, conference rooms. And you can see that it's reporting, September 21st at 3 p.m. This is the illuminance data. It spatializes the results, which is great. Anytime we're looking at daylight simulation tools, we want to be able to get a spatialization of the results so we can relate it to form. But we also need a number that we can start to quantify against. Excuse me. So it reports that for you for the entire building. So this building currently was at 69% daylit for regularly occupied areas according to LEED. The tool also reports each of the individual rooms and what their levels are at. So we can look at the kind of the worst offender, understand that it's at 42%, and start to design a simulation exercise that says, how can we get that up and achieve at least 75%, right? So that's the overall goal. So, we looked at a series of 7 different design modifications. We changed the ceiling heights, we increased the window to wire ratios, we changed the head heights of the windows, we looked at distribution, we looked at light shelves, all of these things, all within Revit, and we're able to run all of these and kind of report out that lab space. And this data is a little bit hard to interpret in terms of which one is better than the other. So we also get the quantity number per room. And then to change the way that looks again is you can rank them on a scale like this and understand that, just changing the ceiling head height from, changing the window head height from 8 foot to 10 feet, actually gives you about a 10% difference. Very small changes leading to those. But we were really interested in this part of the spectrum. What were the changes that had the most effect? So let's take these guys, which was going up to a little bit higher window to wire ratio. We can see that the distribution at that point doesn't really matter in terms of the overall condition. And let's add a light shelf. And then let's rerun the simulation for the entire building to either have improved and are we now compliant, right? So it was a very simple, very logical, rational approach, but very powerful because it only took maybe about a day and a half because we were able to kind of incorporate everything into Revit. So we kind of took those design parameters, gave this back to the design team and said, use those, you should be good. So they came back and they wanted to look at a couple of different schemes. We're looking at their impacts on aesthetics. We looked at a T, L, and R scheme, all pretty much the same parameters. We made sure that they were also compliant. We were also reporting window to wire ratio because we were just interested. And that's where we went from 69% to 79%. They ended up going with the R case. So it was very easy to diagnose the entire building, break it down, identify the area of greatest improvement, rerun an iterative simulation, put that back into the whole building, and make sure that we had achieved credit. So that was kind of a really nice first project for me to get my feet under. Last late design project, and then we'll talk a little bit about post-design. So this is Crawfish Aquatics. It's a series of indoor and outdoor pools, so it's an auditorium. And we also got involved pretty late in this project as well. I believe they were in BE mode, right? So it was post-bid, and they were looking for ways to decrease costs and also increase energy efficiency. So they approached Z and I, and we worked a little bit on doing a lighting audit and tried to identify ways to improve their lighting performance, electrical lighting performance as well. So what we ended up doing is we swapped out 2 lighting fixture types, and we're able to achieve a 6% overall annual cost savings with doing something as simple as doing that. The simulation was the easy part. The amount of emails and phone calls it took to actually change those lighting fixture types was a learning curve for me and how the practice works, but it was a good experience nonetheless. So you can see that these volumes are a series of these kind of shed roof large volumes, and this is all polycarbonate, some clear glazing, and then it's CMU is the other material. So to run the simulations, we actually had to not use the Revit tools because they couldn't handle diffuse glazing. So neither the Sapphira package or the Revit package yet can handle diffuse glazing, which is frustrating. But we're able to take it out and use OpenStudio, which is something we use in the lab that I learned, to actually do the more advanced analysis. So we also had a full-blown energy model from the mechanical engineers, so I didn't have to do the simulation, which was great. Pools are tough. And you can see that the pool energy cost per year is 65%, just heating the pool, dehumidification, stuff like that. So our first question was, should we even think about lighting? What percentage of the overall energy use is from lighting? And does it make any sense to even look at it? So we're able to dissect their model, put it into my favorite double donut chart in Excel, and found out that lighting was in fact 16% of the non-pool energy consumption per year, and that equated to about $25,000 per year. So we're like, okay, well, it seems substantial. Let's see what we can do to reduce that number. So the main kind of lighting for the pool are these giant metal halide fixtures that are over 1,000 watts each. There's 20 of them. There's tons of them in the project. And then another lighting fixture with these kind of lightsabers that are used for pool design. You locate this over non-water, so you can access it and change out the bulb, and then it shoots lights down this kind of translucent tube, and it lights up the rest of the place. But you can see that these guys weren't even used over the pool, so we thought that we could really take these out and swap them out for a more efficient fixture. So these were the ones that we looked at. We found an LED fixture that had the same outputs. We found just kind of a linear pendant that we thought worked for those. We actually saved a little bit of first cost, about $20,000, because we were able to do less because they're more efficient. And then we also were able to cut lighting energy costs by about $9,000 per year with doing just this one very simple swap out. So let's talk a little bit more about how we got those numbers. So this is the table of all of the lighting fixtures multiplied by their wattages. So this is the breakdown of installed watts. You can see that C1 and C2 account for like 80% of everything. So when we swap those out to the more efficient ones, we get a pretty good decrease in the installed power density. And that's something that we're tracking as well. So we want to make sure that all of our projects are 25% better than code for installed lighting power densities. So it was good to get to this level for our own kind of goal setting. So this is just energy. We're able to calculate the difference between that baseline and option 1 with just spreadsheet modeling, very, very simple calculation. But if we wanted to understand the impact of the daylight from the diffuse window conditions, then we had to bring in simulation, which I was happy to do. And that's where we get the jump between 4,000, we double it with the daylight harvesting. So to do that, we run the simulation in OpenStudio. We did it just for one bay. We just extrapolated out, make things easier. And OpenStudio uses radians, which is industry standard, and runs the simulation for every hour of the year. And then you can report every hour of the year in these kind of 2D illuminance maps, similar to what we were seeing with the Revit tool. And this was useful because it actually tells us where we should put our daylight control zones, right? So we extracted the single point in time data to understand, okay, how much of this can be controlled, because we really didn't know how the diffuse lighting was going to perform. and we ended up kind of devising this as our control circuit diagram. And in the program, we have these sensors. They're what's being used to control the actual electrical lighting schedule, and then OpenStudio runs them for the entire year. So let me try to break this chart down a little bit. There's a lot of information. So this is a 12/24/365 plot. It shows every hour of the year on the vertical axis. It shows every hour of the day on the vertical axis, every hour of the year on the horizontal axis across the entire year. And then each one of these colors is the average illuminance value for the entire grid. So it's kind of a proxy, but it gives us a nice annual visualization of how the space is performing. And you'll see that past noon that we actually have a lot higher levels of lighting, and that's because we go back to this, there's actually some clear glass on the west. So as the sun kind of comes around, gets past noon, direct sun hits it, and it bumps up the overall illumination for for the entire grid. So this is kind of a nice visualization. You can dig into it and actually get the daylight autonomy number. And daylight autonomy, the easiest way to think about it is it's the percentage of time where electrical lighting will be off, right? Where there's sufficient enough daylight to actually turn off the electric lights. So when we get this number, we could say, oh, about 50% of the time, we'd be saving substantially on electrical lighting simulation. So let's go ahead and run the full simulation. It pumps all this information back into the energy model, and then we're able to report out the overall savings. So that's where we got the 9,000, and that's where we got the 6% overall for the lighting. So it was kind of a nice exercise going from spreadsheet modeling to daylight simulation back into that spreadsheet model to kind of come up with some of these numbers. So we presented this. We thought it was useful to do, so then we went forward with changing the lighting pictures out in the project and working with the electrical engineer to make sure daylight harvesting was included as well. So that was that impact. The last kind of two things that I wanted to briefly chat about was, so we talked about early design, and we talked about late design, and now post-design or post-occupancy is just as important in general. So one thing that I've been doing a lot of is writing operation manuals and control sequences. So I think Brad has some training on that, definitely, back at the IDL. This is for the Jazz and Heritage Center, New Orleans. It is a performance space, jazz performance space, in a series of classrooms, and they essentially give scholarships or after-school programs for kids to come and learn how to play instruments to kind of keep them off the street. So it's a really great social project as well. It's a multi-split Mitsubishi heat pump system for the classroom spaces, and it's a Train variable air volume system for the performance space. And the actual scheduling is very complicated in that the actual schedules and the itineraries for the classes are variable per semester, so it always has to be rechanged. So we had to think about, how do we write in the process of revisiting the controls, because what usually happens is they'll just run everything from 9 to 5 and that's it. But, it was only operated 3 days out of the week and in the mornings. So we definitely wanted to make sure we were just doing the right setbacks and control sequences to respond to that. Surprisingly difficult. So the maintenance contractor has a controls contract as part of it. So we're really working with him on this document to understand when he goes back in and changes what settings according to scheduling changes. But very interesting of how this starts to kind of pull through. And really, if we would have done energy programming at the beginning, that could have informed a document like this instead of us kind of coming up with it from scratch, looking at the sequence of operations, stuff like that. So this is a nice closed loop in terms of energy programming to kind of post involvement with manuals. The other thing is, we've been doing a lot of monitoring for just environmental conditions after we're out of a project. So this is the new SPCA's office building, Society for the Protection Against the Cruelty of Animals. And it's a fairly complex building. It has a simple mechanical system, and we were getting complaints right before opening of the admin wing was experiencing really cold temperatures. And so we have a lot of hobos at the office, so we're like, okay, let's go instrument them. And let's see if it's just people being squeaky wheels and just being cold in general, or let's see if there's an actual comfort zone issue. So we monitored for about a week. Everything looks pretty good. This is 74. This is 67. We see the setbacks happening properly, and then boom, something is crazy come Monday. And what we found out was that this entire zone is controlled by one thermostat. All the other zones are slaves, common setup depending upon the HVAC system. Thermostat is in this room. This room's up at like 77 degrees. And so it's driving the cooling for all of these zones because it can't maintain temperature. And to make things worse, we dug into the testing and balancing reports, and it was getting like 60% of the airflow that it should have been getting. So it's on the corner, it's getting sun, it doesn't have the right airflow, and it's just causing havoc on all of the other offices. So by us doing this monitoring, we were able to diagnose the problem. We did the forensic investigative work, we changed the system, and then I don't have the post, but it has helped out in terms of that comfort. So this went a long way for, client relations. The CEO is in this office. Just to show that standard of care, I think is really great. And also it helps us understand the impacts of some of our design decisions, because I think if we also would have done energy programming, we probably would have specified a different way to control some of those spaces. The last thing is this is just kind of like a scorecard or checklist in terms of the things that we talked about. So if you're interested in trying to incorporate some of these things, you can start to think about how you address, the structure, the different actions you can take to support that culture, and then here are some of those actionable exercises per design phase that you can start to take back into your firm. So with that, we've made some great strides, I think, in the past almost year and a half. And there's still a lot of other work to do in terms of kind of reaching our goals of having that firm-wide impact overall. So with that, I will open it up for questions. Staying on time, it's amazing. So does anybody have any questions? Sir?
All right, so you had some slides with load counts. Had some slides with load counts in there. I don't know if I saw any engineers or not up here. What's your interaction with engineers on those discussions you have, matching their load counts?
Yeah, so in this case, this is all the first question we get when we show this to engineers, like what's the calculation methodology, right? What are they using to do this? So I dug into the documentation. It's the radiant time series ASHRAE calculation, so it's similar to what we're doing for the heat pump energy savings calculator we developed here at the lab. In a lot of cases, too, a lot of the engineers still aren't comfortable using this other tool. So they're usually doing their own load calcs in their other programs. So in some cases, you can export this out for the geometry of the model that the engineers can use. So there's some workflow savings there. But generally, we have used this mostly just internally, right? Like we don't take these as gospel for the overall numbers, but also still using this kind of relative understanding. Oh my gosh, the wall conduction for this space is huge. Let's kind of work on getting that down. But it's also relatively new that we've been doing this, so we haven't had depth interactions with our engineers yet on these types of tables. That answer your question?
Do you think it's driving integrated design a little bit more?
I think so, yeah. Because, having this information early on, I think definitely would. We can start to understand, okay, well, most of this was, people, what is the assumption? I can call the engineer and say, we've got, X amount of people per square foot. What are you guys going to use for your load calculations? Are we meeting our goal in terms of if we want to use this other HVAC system? I think us having this information early on as architects definitely facilitates asking those questions and having a more informed conversation with our engineers. Absolutely. Tim, I was hoping you'd ask a question.
I was just curious, this is an architecture firm only, right?
Correct.
Rather enough for most of the simulations, and when you talked about Open Studio for some daylight analysis,
yeah.
Are you using eQuest or Open Studio as well?
Yeah, that's a great question. For the most part, everything within Revit has been enough of what we need as architects, and that's been one really hard thing for me to deal with, right? I'm used to going deep with simulations and coming into some of these projects. It's like there's just not the time, right? And I can't quite go to that level of depth, and that level of depth isn't useful for some of the questions that we're starting to answer. So it really is, how do you frame the problem, and what's the quickest and fastest way to get there? But I have used Open Studio when the diffuse material wasn't available in the other tools. We did a lead model to kind of do some relationship building that I had to use Open Studio on. And we also did some parametric infiltration simulation for historic window renovation stuff, because it was just easier to do and set up in Energy Plus. So Yes and no, but mostly it's trying to stay within the BIM integrated tools as much as possible.
Also, while we've got the microphone here, how do the engineers feel about you sticking your nose into that lighting fixtures?
It's a great question. That's a good question. So a lot of times it's been mixed, right? So like I said, that we sometimes will be driving the criteria. Other times, it just really depends on the engineering firm. Some of them are really receptive to it. Some of them, do this themselves. It's all depending upon the level of sophistication of the engineer. But I think overall, I've gotten some pushback on some of the simulations that I've done. Like this showed that the kitchen lighting fixtures were overlighting the space by like 150 foot candles, and there should be 50 foot candles according to whatever reference that you use. And so they're 2x2 LEDs. I'm like, we should space them to 10 feet. We should add a dimming circuit so we can let them tune it. And I was amazing how much pushback I got. And it's like, our experience is this. No, we didn't run a simulation, but we think it should be this. And I ended up just letting it go because I was tired of fighting. We went back to the 8-foot spacing. But that's kind of one of the more negative interactions. The other, I think we've had some, early on before we got to that, we've had some pretty informed conversations about the way this is looking with some of those engineers. And they've actually even commented on some of our other criteria and stuff too. So it has provided a tool to have those discussions, and in any case, some of them go well and some of them go bad. But yeah, we do stick our nose into mechanical engineers' business a lot, and sometimes it's good and sometimes it's bad. But the good ones really, I think, welcome that interaction. I mean, like we're looking at the testing and balance report for some of these projects, and that's should have never gotten to that point to begin with. So depends.
I like to see you guys challenging the engineers.
My boss does it much better than I do. Doug.
Yeah, I'm wondering how you're doing with your project budgets.
Mm-hmm.
Yeah. It seems like this role that you're in is something that's been added to what the architects are doing, and I'm wondering about if they get more money.
Yeah, that's a fantastic question. I forgot to mention it here. One reason why it's important that we're a 50-person firm is that we're large enough to be able to cover some of this by overhead. So my position is split in half. Half of my time is covered by research, which is kind of the overall, overhead by all the projects, and then half of it is directly billable. So I have to kind of be careful how I manage my time so I don't blow up budgets. But the fact that 50% of it is subsidized is really helpful. And we have really great support from the top saying that we want to do projects where we understand that 1% of the budget is going to go towards sustainability exercises and activities. So we're going to take that across the entire board and have this fund for you to work from. Recently, we've been really trying to get some of these things as fee-based items in our project proposals. So we're doing one right now where we're going to be doing reviews of energy audits to kind of look at some of the controls documentation for a new project we have coming down the pipe, and that's actually in the proposal, and there's a separate fee item. So I think people are coming on board in terms of the value that it provides, and now the project managers are getting better at incorporating those into contracts. But it helps that 50% of my time is currently subsidized, and that would be hard to do in a smaller firm.
So if they're committing 1% to sustainability, does that mean that they're 1% part of the design process?
Depends on how you look at it. Yeah, absolutely. And that's one reason why I talked a lot about the kind of the intro to the presentation is if it's seen purely as disruptive, that it can be viewed that way is absolutely appropriate. But if you just change the way that you design that process, then it's like a much less reduced cost add to it. So I think it really depends on how you set that up. How's that for a political answer?
I know we're a little short on time, and this may be a question that is lengthier, but because of your climate specifically, you mentioned natural ventilation.
Yep.
Are you modeling that in any way, or is it a rules of thumb kind of approach to natural ventilation?
It's a great question. So so I gave a presentation at the AIA 2015 convention, national convention, and it was on historic window preservation. And we case studied a project that we were working on for a school, and our main premise is that we should keep the windows as much as possible. If we replace the windows with a high-performance window, we're not getting that much of an energy bonus if we just seal it, if we restore it correctly, and we maintain operability. So we had to do very detailed Energy Plus-based natural ventilation to be able to understand how much more energy were we able to save if we seal the window or if we preserve operability. And that was contingent upon a control sequence that looked at, now not only is there a temperature limit in terms of natural ventilation, but there's a humidity limit or a dew point limit, to be more exact. So it reduces the amount of time that you can do natural ventilation, but we still found that we were able to almost get as good a performance with existing single pane windows that are tight and operable as completely swapping out double pane, completely new windows. We did a little bit of analysis for the Crawfish Aquatics project, but it didn't get beyond, what percentage of the time could we open up these garage doors, to the actual pools. That's about as far as we've gotten with some of those analyses.
So when you need to, you're pulling in Energy Plus for the remodeling in that.
Something like that, it needed to be Energy Plus.
Right now, Revit and its tools does it offer anything as part of this?
It doesn't do natural ventilation. A lot of the prepackaged systems also don't deal with dehumidification straight up, so we have to be careful about what we're comparing to, or if we think that's an absolute value or a relative value that we can compare. So a lot of the simplified tools just aren't there in terms of getting to that level of sophistication, which is problematic for our climate, right? Because humidity drives more often than not. Cool. Well, and I'll stick around afterwards. If anyone has any follow-up questions, I'd be more than happy to stick around. Thanks.
Thank you, Jake. And I just have a quick reminder to please everyone fill out your evaluations. And if you missed it on the way in or came in a little late, there is a sign-in, and we would appreciate if everyone's name's on it. So thank you. Thanks, Jake.